Titan's shocking secrets revealed. The headlines scream across every newsfeed on the planet. For decades, Saturn's largest moon was a hazy orange mystery. Now, data from NASA missions like Cassini and the upcoming Dragonfly expedition have unveiled a world of liquid methane seas, icy mountains, and chemistry that could hint at life. The discoveries are rewriting our textbooks and challenging our ideas about where life could begin. This isn't science fiction. This is Titan. Imagine a place nearly 1 billion miles from the sun, so cold that water is as hard as granite and rain falls as liquid natural gas. Titan is a cosmic drama unfolding before our eyes, a frozen, primordial Earth in the making. The implications are staggering, forcing us to ask, are we alone? Every image of a methane river, every detection of complex molecules, is a clue in the grandest detective story of all time. We're not just looking at a moon, we're looking at a potential cradle of life. Titan's secrets could be the universe's secrets. This is a story about our relentless curiosity and our drive to explore. Our robotic explorers are our eyes and ears, reaching across the void to touch another world. The revelations from Titan are a reward for that ambition. They remind us that the universe is far more strange, wonderful, and full of possibilities than we ever dreamed. The journey to Titan is a testament to human ingenuity, and the story is just beginning.
Titan is a giant, bigger than Mercury, orbiting Saturn 10 times farther from the Sun than Earth. It receives just 1% of our sunlight, locking it in a deep freeze at -290 degrees Fahrenheit. Here, water is rock hard, forming the crust in mountains. But Titan's true uniqueness is its thick, dense atmosphere, denser than Earth's. The pressure is 50% higher than at sea level on Earth. With low gravity and thick air, you could strap on wings and fly. Titan's atmosphere drives weather, geology, and chemistry. Unlike our airless moon or Ganymede, Titan is dynamic, with seasons, wind, clouds, and rain. But here, the rain is methane, not water. Titan is a distorted mirror of Earth, familiar processes, but with alien ingredients. It's a natural experiment. What happens when you build a world with methane instead of water? Titan forces us to broaden our definition of what a world can be. It's not just a moon, it's a planet-like body, offering a glimpse into a different path of planetary evolution, and maybe, just maybe, a different kind of life.
Step into Titan's atmosphere, a realm of perpetual twilight and orange haze. This haze is made of tholins, complex organic molecules formed by sunlight and Saturn's magnetic field breaking down methane and nitrogen. The result? A smog that rains down, blanketing Titan in organic material and hiding its surface from view. Titan's atmosphere is mostly nitrogen, like Earth's, but with about 5% methane and traces of other hydrocarbons. On Titan, methane acts like water on Earth, cycling between solid, liquid, and gas. Methane evaporates, forms clouds, and rains back down. Imagine standing on Titan, feeling a drizzle of liquid methane. The weather is extreme. Clouds of methane and ethane, winds shaping hydrocarbon dunes, and oily methane rain. Massive storms can cause floods, carving channels into the icy landscape. Titan's nitrogen-rich atmosphere is a puzzle, likely built from ammonia ice, released over eons. Methane is constantly replenished, perhaps by cryovolcanoes or subsurface reservoirs. This active, complex atmosphere makes Titan a top target in the search for life. It's a world where chemistry is always at work, and it's unlike anything else in the solar system. Titan's sky is a laboratory for the origins of life. Peer through Titan's haze and you'll find a landscape eerily Earth-like in form, but alien in substance. Mountains of water ice, cryovolcanoes like doom mons, and plains shaped by wind and rain. Fewer craters than our moon reveal a young, active surface, but the showstoppers are Titan's lakes and seas of liquid methane and ethane, concentrated near the poles. Kraken Mare, the largest, dwarfs North America's Great Lakes. Rivers and valleys feed these seas, making Titan the only other place with stable surface liquids. Cassini even captured sunlight glinting off these alien lakes, a breathtaking first. These rivers and seas are chemical reservoirs, dynamic systems transporting materials across the moon, and they may be the best place to search for life unlike any on Earth. Our first close-up look at Titan came from the Cassini-Huygens mission, a triumph of engineering. Cassini orbited Saturn, but its passenger, the Huygens probe, was built to land on Titan. Released in December 2004, Huygens plunged into Titan's atmosphere weeks later, protected by a heat shield and slowed by parachutes. For over 2 hours, it drifted through the haze, measuring temperature, pressure, and chemistry. Its cameras revealed branching river networks and coastlines, direct evidence of liquid-carved features. Huygens landed on a solid, damp surface, not a sea, but a floodplain of rounded water-ice rocks. The ground was like wet sand, with a hard crust and softer material beneath. For 72 minutes, Huygens sent back the first images and sounds from Titan's surface. The rocks were water ice, shaped by methane flows. Even the wind was recorded, blowing across this alien world. Huygens gave us our first ground truth, a real look beneath the clouds. Titan became a place, not just a mystery. Weather, geology, and landscape came into focus. The mission was a spectacular success, and it changed how we see Titan forever. While Huygens gave us a brief glimpse, Cassini was our long-term eye on Titan. For 13 years, Cassini made over 125 flybys, using radar to map Titan's hidden surface. It discovered lakes, seas, rivers, and vast dunes. Cassini's instruments tracked clouds, seasons, and even waves on Titan's seas. By measuring Titan's wobbles, Cassini revealed a global subsurface ocean of salty water hidden beneath the ice. This was a game-changer. Liquid water, the key for life, exists on Titan. In 2017, Cassini's mission ended with a dramatic plunge into Saturn, protecting Titan from contamination. Cassini transformed Titan from a mystery to a complex, active world. It laid the groundwork for future exploration, and it left us with tantalizing new mysteries. The discoveries of Cassini and Huygens demand a return to Titan. Enter Dragonfly, a nuclear-powered drone set to launch in the late 2020s. Dragonfly will fly through Titan's thick air, hopping from site to site, exploring diverse landscapes. Its design is perfect for Titan's dense atmosphere and low gravity. Each flight covers miles, followed by days of ground investigation. Dragonfly is a mobile chemistry lab, searching for the building blocks of life. It will land in organic-rich dunes, then leap toward an impact crater where water and organics may have mixed. Its instruments will hunt for amino acids and other complex molecules. Dragonfly will also study Titan's habitability, its ocean, methane cycle, and weather. For the first time, we'll explore Titan's surface in depth. This is the big question. Could there be life on Titan? Life as we know it needs liquid water. So if it exists, it might be deep in Titan's subsurface ocean. There, life could survive on chemical energy, like Earth's deep-sea vents. But Titan pushes us to imagine life as we don't know it, maybe even methane-based life on the surface. Methane isn't a great solvent, and the cold slows chemistry, but over billions of years, could something strange emerge? Titan's atmosphere and surface are factories for complex organic molecules. The ingredients are there: nitrogen, carbon, hydrogen, methane, and energy. Could some of these compounds organize into self-replicating structures? Maybe methane-based microbes float in Kraken mare, metabolizing acetylene and breathing hydrogen. We have no evidence yet, but the conditions might be right for prebiotic chemistry, or even alien biology. The search for life on Titan is about testing the limits of biology itself. If we find life, it could mean life is a fundamental property of the universe. Titan could change everything we know about life. Titan has changed our perspective on the search for life. For centuries, we followed the water, looking for habitable zones like Earth's. But Titan doesn't fit. Too cold, too far, with methane seas instead of water. Yet, it's one of the most intriguing places to search for life. Titan shows that the ingredients for life, atmosphere, organic chemistry, a liquid cycle, can exist in unexpected places. It forces us to broaden our definition of habitability. Titan is a prebiotic chemistry lab, a snapshot of early Earth preserved in deep freeze. Whether or not we find life, exploring Titan teaches us about the cosmos and ourselves. As Dragonfly prepares to fly, we're not just exploring a moon. We're pushing the boundaries of possibility. And we're asking the most human question of all. What else is out there?